Hello everyone. So our today's point is vibration of an air column in a pipe closed at one end. Vibration of an air column in a pipe closed at one end. So that pipe is what closed at one end. So you can see these are what modes of vibrations. These are what modes of vibrations. So in this point we are going to study about the vibration and its frequency. Vibration and its frequency. So for this let us consider a tube. Let us consider a cylindrical tube of length L. Let us consider a cylindrical tube of length small l. Okay, let us consider a cylindrical tube of length L. So this tube consists of what? Air columns. So this tube consists of what? Air columns. Here are what? Air particles. Here is what? Air column. So this tube consists of what? Air particles or the air column with one end closed. With one end closed. So when a vibrating tuning form is placed at the open end of this closed pipe, when a vibrating tuning fork is placed at the open end of this closed pipe, so this vibrating string, this vibrating fork produces what? Sound waves. This vibrating tuning fork produces what? Sound waves, and these sound waves are moving in this pipe. Okay, so the sound waves produced by this tuning fork is moving in the tube. So here you can see as the tuning fork is placed at the open end. So the sound waves are sent by the tuning fork is moving in this tube. So we know that sound waves are longitudinal waves. Sound waves are what? Longitudinal waves. So as the here you can say that longitudinal waves are moving in this tube, or the longitudinal waves are traveling along the tube. The longitudinal waves are traveling along this tube. Okay, so as the longitudinal waves are traveling in this tube, as the longitudinal waves are traveling in this tube, here you can see this end is what? Rigid end. So this is what? Rigid end. So because of this rigid end, these longitudinal waves get reflected. Okay, so as tuning fork is placed, longitudinal waves are moving in the tube. Longitudinal waves are moving or traveling in the tube. So as this end is what? Rigid. As the end is what? Rigid. So these waves get reflected. That waves get reflected because of this closed end. Because of this closed end. So phase of these reflected waves. So as the waves are moving in this direction, so because of this rigid, so these waves get reflected. So the phase of these reflected waves, the phase of these reflected waves depend upon either the pipe is closed or open. Okay, so as the wave is reflecting, so that phase of this reflected wave, depends upon either the pipe is closed or open. So if the pipe is open, so reflected, there is what? Partial reflection, but here is what? Complete reflection, as the end is what? Closed. So the phase of the reflected waves depends upon either the pipe is closed or open at both ends. So or it is also depends upon the pipe is narrow or wide. So as the pipe is narrow or wide, so phase of that reflected wave depends upon this, as the pipe is wide or narrow. Okay, so you can see in this diagram, so at this closed end, and here is what? Open end. This is what? Closed end, and this is what? Open end. Okay, so at the closed end you can see there is what? Only nodes, and at the open ends there are antinodes. Why? So why? So you can see at the closed end the particles of the medium, the particles at the closed end, the particles at this closed end. So here are what? Particles at this closed end. So there are number of particles in this air column. There are what? Number of particles in this air column. So particle at the closed end, the particles at the closed end have least freedom for the motion. Here you can see these particles have what? Least freedom. So particles at this position, have what? Least freedom for the motion. So it can vibrate or it can oscillate with minimum displacement. It can vibrate or oscillate with what? Minimum displacement. And the particle which have minimum displacement are what? Nodes. So at the closed end there are what? Always a node. At the close point there always or must be a node. Okay, and the open end, slightly beyond the open end, not exactly at the open end. So at this point you can say this is what? Open end. This is what? Open end. So but antinodes are not exactly at the open end, as we have seen in the end correction. So because of what? This particle can vibrate freely at this position. So particles at the open end slightly beyond the open end, slightly beyond the open end. So this is the open end. Actually this is open end, but this is, here you can see the particle is what? Slightly beyond the open end. So the particle slightly beyond the open end are most free to vibrate. Here you can see the particles can vibrate up to this. So this particle can vibrate up to this, means it has what most freedom to vibrate. So these particles have most freedom to vibrate. These particles have what most freedom to vibrate. So this particle can give maximum displacement. This particle can give maximum displacement, and the particle which has maximum displacement are what antinodes. So antinodes are always formed at the slightly beyond the open end. Antinodes are always formed slightly beyond the open end. So nodes are always at the close end, and antinodes are always at the or slightly beyond the open end. Antinodes are always slightly beyond the open end, because here the particles can move freely as compared to this. So this particle can vibrate up to this. So there is what maximum displacement, here is what minimum displacement. So particle vibrate up to this because of this rigid. So here you can see the particle can vibrate up to this, but this particle can vibrate with maximum displacement. These particles can vibrate with the maximum displacement. Hence nodes are always at the close end, and antinodes are always at slightly beyond the open end. So here what antinodes and the nodes. Okay. So for in the first figure, this is what first mode of vibration, this is the second mode of vibration, and this is the next mode of vibration. Okay. So in this mode of vibration, this is what first mode of vibration. So figure A shows the first mode of vibration. Figure 1A shows the first mode of vibration. First mode of vibration. First mode of vibration. Vibration of an air column in a pipe closed at one end. So this pipe is what closed at one end. So figure 1A. Figure 1A shows the first mode of vibration, in which the vibrations of the air column is taking place. Okay. So here you can see, as the tuning fork is here, so these vibrations of the particle is happening in this air column. So here you can see, so length of this tube is what? Small l. So length of this pipe or the tube, length of the pipe is what? Small l, and the length of air column. So this is, here you can see, small l is what? Length of the pipe, and capital L is the length of this air column, means what? From antinode to node. So this is what? Total air column for this tube. Okay. So small l is what? Length of the pipe, and capital L is what? And the capital L, length of the air column is capital L, as shown in all figures. So you can see in all figures or the all modes of vibration, L is what? Length of an air column, but this small l is what? Length of this tube, and air column is what? This. So L is what? Length of air column, and small l is what? Length of the pipe. So on that diagram you can see. So in all diagrams we have shown this. Okay. So this is what? This is the basic or the simplest mode of vibration. Okay. So these are what? Modes of vibration, but this is the simplest mode of vibration. And it is called as what? Fundamental mode. So these are what? Modes of vibrations. And this is the simplest form or the basic form of mode of vibration. So this is the simplest form of mode of vibration, and it is called as what? Fundamental mode. Okay. So figure 1A is the simplest mode of vibration, and it is called as fundamental mode. called as what? Fundamental mode. Fundamental mode. So this is what basic or the minimum fundamental mode. So that is known as what? So basic mode of vibration. This is known as what? Fundamental mode. So for this, length of air column is, so length of, from this figure, that is what? Figure A. So length of air column is, length of air column, that is what? Capital L. Length of air column, not the length of pipe. Length of air column is what? Lambda by 4. Why it is lambda by 4? We know that. So this is what? Wavelength. So wavelength is what? The distance traveled by the wave to complete one oscillation. So this is what? One oscillation total is what? Lambda. So half of this is what? Lambda by 2, and half of this is what? Lambda by 4. Half of this one loop. So this is what? Half of loop. So here is what? Here you can see. So this total is what? Lambda. This total, sorry, this total is what? Lambda. But half of this is what? Lambda by 2, and half of this part is what? Lambda by 4. So this is what? Lambda by 4. Okay. So this is what? Lambda by 4. So here you can see. So this is what? Lambda, and this is what? Half lambda. So this is what? 3 lambda by 4. So this is what? Lambda by 4. This is what? Length of air column in a pipe. Length of air column in a pipe. So length of air column in this pipe is, so L is equals to what? L is equals to lambda by 4. Lambda by 4. So therefore lambda is equals to 4L. Therefore lambda is what? 4 in this direction. So 4L. Let us consider this is equation number 1. So where lambda is what? Where lambda is the wavelength. Where lambda is the wavelength. Where lambda is what? Wavelength. Where lambda is what? Wavelength. And if n is the frequency, and if n is the fundamental frequency. Why fundamental? Because this mode is what? Fundamental mode. So fundamental mode has what? Fundamental frequency, as we have seen in the harmonics and the overtones. So where lambda is the wavelength, and if n is the fundamental frequency, if n is the fundamental frequency, then we know that V is equals to what? N lambda. V is equals to what? N lambda, that equation. So V is equals to what? N lambda. So therefore frequency of this mode of vibration, N is equals to what? V by lambda. So frequency of mode of vibration is what? V by lambda. So what is the value of V? V as it is. So lambda is what? 4L. Lambda is what? 4 capital L. 4 into capital L. So from the diagram you can see this L is what? Capital L is the length of air column, but small l is what? Length of the pipe. So here is what? End correction. Here is what? End correction, because antinodes are not exactly formed at the open end, slightly beyond the open end. Antinodes are formed at slightly beyond the open end. So here is what? End correction. So that capital L is equals to what? Small l plus e. So this total distance is what? Small l plus e. Okay. So V upon 4 in bracket small l plus e. Small l plus e. So this is what? Frequency. Let us consider this is equation number 1. Okay. So here you can see this is what? Length of an air column. Length of this air column. So that is what? So this total distance you can see this is what? Small l plus e. So where e is what? End correction, as we have seen in the previous lecture. So 4 in bracket L plus E. So this is what? Frequency. So as this is what? Fundamental mode. So this is the lowest frequency. This is what? Lowest frequency in this mode of vibration. In this modes of vibration. So this is the lowest frequency. This is the lowest frequency. This is the lowest frequency, and it is called as what? Fundamental frequency. This is lowest frequency, and it is what? Fundamental frequency, and it is also called as first harmonic. It is also called as first harmonic. So the fundamental frequency is also known as what? First harmonic. Okay. So the basic of this frequency or minimum of this frequency. So this is what? Minimum frequency. Lowest means minimum frequency, and the minimum frequency of mode of vibration is what? Fundamental frequency, and that fundamental frequency is also known as what? First harmonic. This fundamental frequency is also known as what? First harmonic. Okay. So for the next mode of vibration, so as we have seen this frequency for this mode of vibration in figure A. So for the next mode of vibration, next mode of vibrations in figure B, B. For the next mode of vibration in figure B, so here you can see this is air column, this is what length of air column, this is what length of pipe. So if we vibrate this air column in such a way that, if we vibrate this air column in such a way that, so this consists of, this air column consists of, or this vibration consists of a node at its ends, a node at its end and an antinode at its open end, a node at its end and an antinode at its open end, and there is one more node and one more antinode in between. Okay, so we are vibrating this medium, in such a way that, a node is at end and an antinode is at open end, and there is one more node and one more antinode in between. So we are vibrating the air column like this, in this. Okay, so where the node is at close end and one node antinode is at open end, and one more node and one more antinode in between. So like this. So this is what shown in figure B. So the next mode of vibration is shown in figure B. So here you can see the node is at close end and open end is at this, and there is what one more node and antinode in between. So if the frequency of this mode is N2, if the frequency of this mode is N2, so for this mode, this is first mode, this is what second mode. So for this mode, let us consider, N2 nahi, N1. So frequency of this mode is what? N1, and wavelength is what? And wavelength is lambda 1. Okay, so frequency of this mode is what? N1, and lambda 1 is what? Wavelength of this mode. So that is what? Lambda 1. Then length of this column, length of this air column. So what is the length of air column is what? Capital L, and which is equals to what? 3 lambda 1 upon 4. Why? You can see this is what? So this is what? Half portion is what? Lambda by 4. So if this is lambda by 4, this is lambda by 4, and this is lambda by 4. So total is what? 3 lambda by 4. So if this is what? Half portion is what? Lambda by 4. So this is lambda by 4, and this is what? Lambda by 4. So total length will be 3 lambda by 4. But here is what? Wavelength lambda 1. So 3 lambda 1 by 4. Okay, you can see here. So half portion is what? This half portion is what? Lambda by 4, as we have seen in the wave. So this next half is what? Lambda by 4, and here next half is what? Lambda by 4. So total distance will be 3 lambda by 4. 3 lambda by 4. And here is what? Frequency, or sorry, lambda wavelength is what? Lambda 1. So 3 lambda 1 by 4. Okay, for next same, but we are dealing with this mode of vibration, this. So length of the air column is what? 3 lambda 1 by 4. Length of this air column is what? 3 lambda 1 by 4. 3 lambda 1 by 4. So from this, what is the value of lambda 1? Lambda 1 is equals to 4L upon 3. 4L upon 3. Here you can see capital L. Capital L is equals to what? 3 lambda 1 by 4. So what is the value of lambda 1? Lambda 1 is equals to 4L upon 3. So 4 upon 3. So this L is what? Small l plus e. Because here is what? Here is also an end correction. So this is what? Actual length of an air column, or the corrected length of an air column, which is equals to what? Small l plus e. Small l plus e, as we have seen in the end correction. So lambda 1 is equals to 4L upon 3, which is equals to 4 upon 3 in bracket L plus e. So this is what? Wavelength. So frequency for this. So the velocity of this mode is, so what is the velocity of this mode is, so v is equals to n1 lambda 1. So velocity for this mode, as we had seen in this, so velocity for this mode is equals to what? V is equals to n1 lambda 1. So therefore n1 is equals to v divided by lambda 1. So let us consider this is equation number 3. Okay, so n is equals to what? N1 is equals to v divided by lambda 1. So what is the value of v? Same, lambda 1 is what? Lambda 1 is this. So 4L upon 3. So value of this is what? 4L upon 3. So this is what? 3v divided by 4L, or we can write this as 3V divided by 4 in bracket L plus E, because this capital L is what? Small l plus E. Okay, so 3V upon 4 in bracket L plus E. So here you can see this is what? Fundamental frequency. So fundamental frequency is what? V upon 4 in bracket L plus E. So we can write, therefore N1 is equals to 3. So this 3 is as it is. So V upon 4 in bracket L plus E. V upon 4 in bracket L plus E is what? Fundamental frequency. Is what? Fundamental frequency. So let us consider this is the equation number 4. So this is what? Frequency of this mode of vibration. So here you can see this is what? Frequency of third harmonic. Frequency of third harmonic. So this is what? Frequency of first harmonic. So here you can see N is what? This. So here is what? N. So this value is what? N. So N1 is equals to 3N. So this is the frequency of third harmonic. This is the frequency of third harmonic. Frequency of third harmonic. Third harmonic. And it is called as first overtone. Is called as first overtone. First overtone. Okay, so this is what? Next mode of vibration for this frequency is what? Third harmonic. This is what? Frequency for the third harmonic, and it is called as what? First overtone. It is called as what? First overtone. Okay, so remember that overtones are always come in sequence. Overtones are always come in sequence, but harmonics depends upon the waves. Harmonic depends upon the waves. As here you can see, first harmonic, after that third harmonic. So not in sequence, but overtones are always, remember that overtones are always come in numerical sequence. Numerical sequence. So this is what? Frequency of the third harmonic, and it is called as what? First overtone. It is called as what? First overtone. So this is what? Mode of vibration, and for this mode of vibration, this is the frequency. So this is what? Third harmonic. This is what? Third harmonic. So for this mode of vibration, so for next mode of vibration, shown in figure C, you can see here is what? Air column. So that air column is vibrated in such a way that this air column is vibrated in such a way that, so there is a node at the close end, there is a node at the close end and an antinode at the open ends. There is a node at the close end and there is an antinode at the open end, and there are two more nodes and there are two more antinodes in between. Okay, so we are vibrating this air column in such a way that, so there is a node at the close end and one antinode at the open end, and there are two more nodes and two more antinodes in between. Two more nodes and the two more antinodes are in between. So like this we are vibrating this air column. Okay, so for this you can see this is the loop structure. This is the loop structure as we are vibrating this air column. So if N2 is the frequency, of this mode of vibration, if N2 is the frequency of this mode of vibration, and lambda 2 is the wavelength, then so what is the length of air column? So length of air column is what? 5 lambda 2 by 4. So 5 lambda by 4. So as here is what? Wavelength is lambda 2. So 5 lambda by 2. So 5 lambda 2 by 4. So here you can see, so half of this is what? This is lambda by 4. So this is lambda by 4, this is lambda by 4, this is lambda by 4, lambda by 4, lambda by 4. As what? Here you can see like this. Okay, so here is what? This is what? Lambda by 4. So this is what? Lambda by 4. So all these are lambda by 4. So here you can see lambda by 4 plus lambda by 4 plus lambda by 4, lambda by 4. So total is what? 5 lambda by 4. As here is what? 3 lambda by 4. So this is what? 3 lambda by 4 plus this lambda by 4 plus this lambda by 4, 3 lambda by 4. For here is what? 5 lambda by 4. So length of the air column, length of the air column is, so what is the length of air column for this mode of vibration is what? 5 lambda 2 by 4, 5 lambda 2 by 4, 5 lambda 2 by 4. So for this, from this equation, lambda 2 is what? Lambda 2 is equals to 4L upon 5. Lambda 2 is equals to what? 4L upon 5. Let us consider this is equation number 5. Okay. So this is what? Lambda 2 wavelength for this mode of vibration, or wavelength of this mode of vibration. So similarly for frequency, so the velocity of this mode, the velocity of this mode, velocity of this mode is what? V is equals to n2 lambda 2. V is equals to what? n2 lambda 2. So therefore n2 is equals to V divided by lambda 2. n2 is equals to what? V divided by lambda 2. So V is what? As it is. So lambda 2 is what? 4L upon 5. 4L upon 5, which is equals to 5V upon 4L. 5V upon 4L, or we know that this L is what? 5V upon 4, this L is what? Small l plus e. So this is what? Correct length of an air column. So which is equals to what? L plus e. L, and here is what? End correction. Here is also an end correction because of this open end. So 4 in bracket L plus e. So this is what? So here you can see V upon 4L plus e is what? Fundamental frequency. V upon 4L plus is what? Fundamental frequency. So therefore N2 is equals to what? 5N. N2 is equals to what? 5N. So V upon 4 in bracket L plus E is what? So this is what? N, and 5 as it is. So N2 is equals to what? 5N, and this is the, this frequency is the fifth harmonic. Here you can see 5. So this frequency is what? Fifth harmonic. This frequency is the fifth harmonic. This frequency is the fifth harmonic. Fifth harmonic, and it is called as what? Second overtone. So as here is what? First overtone, then it is what? Second overtone. It is called as second overtone. It is called as what? Second overtone. It is called as what? Second overtone. So let us consider this is equation number 6. So this is the frequency for the, this is the frequency for this mode of vibration, and it is called as what? Fifth harmonic, and it is also called as what? Second overtone. Second overtone. Okay. So for this mode of vibration, for the next mode of vibration, as there is what? Next mode of vibration. After this is what? 7 lambda by 4, and this is the length. Means what? Next mode of vibration. So similarly for the next mode of vibration, we can write the equation for frequency. So for the next modes of vibration, for the next modes of vibrations, the frequencies, so the frequencies will be, so here you can see, after that here is what? N, you can see here is what? 3N, after that 5N, means what? Odd numbers. So after that, after 5 here will be 7N, after that 7N, after that 9N, etc. So here is what? Here only odd harmonics are present. Here you can see after 5, so here you can see 1 3 5, 1 3 5 7 9, means what? Odd harmonics. So and the general formula for the frequency for the pith overtone, for the pith overtone, general formula of frequency, the frequency is so NP is equals to 2p plus 1 into n, 2p plus 1 into n. So this is what? Equation number 7. So this is the general formula for the frequency, means what? Next modes of vibration. So here you can see only odd harmonics are present, only odd harmonics are present. So even harmonics are absent in this. So what we can say? So in the closed end pipe, or the pipe which is closed at one end, only odd harmonics are present. What we can say from this? So from this we can say that is what? Only odd harmonics are present in a pipe which is closed at one end, and the even harmonics are absent in this. Even harmonics are absent in this. So by using this, or by using this description, or by this description, we can conclude that. Okay, so only odd harmonics are present in a pipe closed at one end. Only odd harmonics are present in a pipe which is closed at one end, and even harmonics are absent in this. Even harmonics are absent in this. Okay, so this is all about the vibrations produced in a pipe which is closed at one end. So in the next lecture, we are going to study vibrations of an air column in a pipe which is open at both ends. Which is open at both ends, as there are two types of pipe. So one pipe is what, closed at one end, and the second one is what, the pipe which is open at both ends. Okay, so in the next lecture we are going to study that. Okay, so if you have problem regarding to this, you can ask me. Okay, thank you very much.